So today what we're going to do is continue our discussion of demand and supply. We had started through the discussion of consumer behavior as reflected in the demand curve last time. We're going to finish that up, and then we'll be able to quickly go through supply because the sort of definitions are very analogous. So we'll be able to get through the finishing up demand today and the discussion of supply today. So that will leave us ready to put it all together next week and actually be able to use the model next week. Friday, of course, you'll have a quiz based on this week's material, and then the exercises are about putting demand and supply together, about market equilibrium. So that's sort of the balance of the chapter. If you've been reading the assignments, that'll be the balance of the chapter that you have read so far for the team exercise. Good? All right. So we had finished last time. We had gotten to the point where we made the ceteris paribus assumption, remembering that ceteris paribus means all else equal or all else constant. So it was the cheat we use, if you will, to deal with the many-dimensional problem, right? So we end up with just 2 dimensions that we can draw pictures of, put in a table, think about using symbol algebra, as opposed to the 7 or more dimensional problem that we defined in terms of consumer behavior. So we ended with these definitions, and I just want to start there so we're all on the same page. So we defined 3 ways of looking at the ceteris paribus demand relationship. The demand schedule, which we said was a tabular form, right? So where we would put prices and quantities in a table. The demand curve, which is a graphical form. So where we graph quantity demanded on the horizontal axes and price on the vertical axes. Remember that this was one little sort of, if you will, weird thing about economics is that we put what is in effect the y variable, the dependent variable on the horizontal axes as opposed to on the vertical axes. That's important because then we want to remember that we're always measuring along that axis. So we're thinking left and right along the horizontal axes, along the quantity axes, as opposed to up or down. But the demand curve, just again, relates price to various quantities, just like the table did. By the way, some people get freaked out by that. We call it a curve, even though this is a straight line, right? A curve is a generic term for a graphical representation. So it may be linear, it may be nonlinear, but curve we use for either case. So don't think it's straight, so it can't be a demand curve. And then the final way we could examine the relationship between price and quantity demanded, ceteris paribus, is we could use a demand function, right? And a demand function is just an algebraic expression that shows the relationship between price and quantity demanded, holding everything else constant. So this example here, where quantity demanded, say, is 1200 minus 100p, we would be able to substitute various prices, right? So we could substitute, for example, $2 in for p, and if we substitute in $2, multiply by 100, and subtract that from 1200, and then that would give us, of course, 1200 minus 100 times 2. 100 times 2 is 200, so that would give us quantity demanded of 1,000. We could put in $4 for p. 4 times 100 is 400. 1200 minus 400 would be 800. Quantity demanded would be 800 when the price was 4, and so on and so forth. So you just substitute various prices in for the p in the demand function, and that would tell me what quantity demanded is. Yes? Okay. So all 3 of these things, the demand table, or demand schedule, excuse me, the demand curve, and the demand function, are 3 different ways of looking at the exact same relationship. And what I've done here is actually use the literally exact same relationship, right? Because the table shows me that at a price of $2, quantity demanded is 1,000. The graph shows me that at a price of $2, quantity demanded is 1,000. And the expression, the algebraic expression, the demand function shows me that if I plug in $2, I get quantity demanded of 1,000. So these are all exactly the same relationship between price and quantity demanded, just 3 different ways of looking at it. Make sense? So what can you tell me about the relationship in this example? What's the direction of the relationship between price and quantity demanded? Is it?
It's an inverse relationship.
It's an inverse relationship, right, exactly. In other words, the 2 variables move in opposite directions. So when price goes up, quantity demanded goes down. Higher prices lead to lower quantity demanded. And vice versa. When price goes down, quantity demanded goes up. So they move in opposite directions, which is what we call an inverse relationship, or sometimes a negative relationship, right? An inverse relationship or a negative relationship. Good. That's not just by chance and was not just by this example, okay? The relationship between price and quantity demanded, ceteris paribus, is, for all intents and purposes, always expected to be negative. Economists refer to this as the law of demand. The law of demand simply says that price and quantity demanded are inversely or negatively related ceteris paribus, holding everything else constant. When price goes up, quantity demanded will go down, and when price goes down, quantity demanded will go up. In other words, if I look at the demand curve, it will have a negative slope. It will slope from upper left to lower right. It will slope from upper left to lower right. Makes sense? The law of demand, by the way, is based upon observed behavior and consistently observed behavior. If you choose at some point in your lives to take intermediate microeconomics, which is sort of the continuation of this course, you will learn that given pretty reasonable assumptions, you can actually imagine a situation in which you could have an upward sloping demand curve. An upward sloping demand curve was described in like the late 19th century by an economist named Robert Giffen. So we call it a Giffen demand curve or a Giffen good. However, ever since then, empirical economists have tried to document a human example of a positively sloped demand curve and have never been able to do it. So for all intents and purposes, the law of demand is true, even though we can imagine situations in which it might not be. The only documented case of a positively sloped demand curve that I know of is one in an experiment using rats and pigeons as opposed to human beings. So I don't think anyone's ever done it outside of animal experiments. For your purposes, demand curves will always slope downward, right? Never draw one that goes the other direction. Good? Okay. Then the last thing we want to do in terms of the demand side of this whole thing is a couple definitions, which again I asked you to explore last week in your team exercises, so I think you know this already, but these are so important we need to spend a little bit of time just talking about them again. Okay, these terms are really important that we use them correctly and we use them consistently, so it's important that we think about them. We make a distinction between two things that sound very, very similar to one another. What we call a change in quantity demanded and a change in demand. Okay, a change in quantity demanded and a change in demand. And really what this has to do with is whether or not the ceteris paribus assumption holds, right? So if we're looking at a situation where all else has remained constant, or a situation in which one of those other determinants besides price, something other than price has changed, income, tastes and preferences, the number of buyers, the price of related goods and consumption, or consumer expectations, okay? So we're trying to distinguish a situation in which those things have remained constant from when those things have changed. We consider the situation a change in quantity demanded when ceteris paribus has held, when nothing but price has changed. So if something in a market causes price to change, we will move along the given demand curve, okay? This is a change in quantity demanded. So if price rises from $4 to $8, for example, for whatever reason, something in the market's changed that caused price to rise, quantity demanded will respond by decreasing, right? In the example we've been working with, quantity demanded decreases from 800 units when price was $4 to 400 units when price is $8. That movement from the point where price was 4 and quantity demanded was 8 to the point where price is 8 and quantity demanded is 400, that movement up along the demand curve is a decrease in quantity demanded. Okay, that is a decrease in quantity demanded. Make sense? By the way, be careful of this. Which direction are we moving along the demand curve? Yeah, like in terms of like space, it's kind of up, right? But it is to the left along the demand curve, and that's why this is a decrease, right? Because as we move from here to here, quantity demanded is going down because we're moving closer to the origin, right? So again, we're moving left along that demand curve is the appropriate way to say it, really, not up. It's rather confusing if you say we're moving up and that's a decrease. Good. We should contrast that situation with a situation in which something besides price has changed. Okay, one of those non-price determinants of demand, income, taste, and preferences, the number of buyers, the price of related goods, and consumer expectations. We should contrast it with that. Because if one of those items has changed, the demand curve, or demand schedule, or demand function we're working with, is no longer valid. Because we drew the demand curve, we created the demand schedule, we wrote the demand function, assuming ceteris paribus, assuming that everything else was constant. So if one of those other things has changed, that demand curve schedule table demand schedule curve or function is no longer valid. We need a new one. We need one that reflects the new level of income, or the new level of tastes and preferences, or the new level of expectations, and so on and so forth. So you have to draw an entirely new demand curve, because it doesn't matter what the price is. Consumer behavior is now different. Whether price is $2 and income is higher, that causes a different demand, a different relationship with price and demand. If price is $4 and income changes, it's different than it was before. So we need an entirely new demand curve. This is a change in demand, right? So change in demand means that something other than price has changed. So for example, tastes and preferences, we talked about this one last time, so like we see our favorite consumer who had, or our favorite celebrity who's using the product, and now we want to use the product too. That might be an increase in taste and preferences. So now it doesn't matter what the price is, right? It doesn't matter whether the price is high or the price is low. People want more of the product because of this increase in preferences or increase in taste for the particular product. So at every price, we're going to go from the old quantity demanded to a new quantity demanded that's higher. At every price, from the old quantity demanded to a new quantity demanded that is higher. So we will have an entirely new demand curve that lies to the right of the old demand curve. Make sense? Yes. Okay. That is an increase in demand then in this case, because again, the demand curve is to the right, and at every price, quantity demanded is higher. Good? Okay. Those are all our definitions related to demand. So are we good with the concept? So we have quantity demanded, which is basically the desired demand, desired consumption of a group of consumers. We relate it to price, holding everything else constant. We know that the law of demand, so those two things, price and quantity demand, should be inversely related if we hold everything else constant. And we understand the definition of change in demand and change in quantity demand. Okay. We can run through the exact same sort of discussion on the producer side of the market. Remember, producers are in business to maximize profit, subject to like some sort of technology constraint, right? There's so much that they can produce given costs and technology and available resources, but they're trying to maximize profit through the production and sale of goods and services. So we will start at the same place with a very similar definition to what we started with consumers. Here we'll talk about quantity supplied. Quantity supplied is the amount of a product that a group of producers are willing and able to offer for sale at various prices. Again, this is the desired sales of the producers. Notice, it's what they are willing and able to offer for sale. It's not necessarily what they sell, right? It's what they want to sell. It's what they offer for sale. And once again, we could think about a whole selection of things that determine what quantity a group of producers are willing and able to offer for sale. Okay? And again, you talked about these with your teams last week, but let's just run through the list to make sure we all understand what they are. The first item is once again going to be price. And by this I mean the price of the product itself that we're talking about, right? So the price of the product, what they can get from the consumer. If you're a producer, how do you think the amount that you're willing and able to offer for sale is affected by price? If price goes up, would you want to sell more or would you want to sell less? I would want to sell more, right? Because I'm trying to maximize profits, right? So holding everything else constant, if I can sell at a higher price, that would increase my profits, right? It's more revenue for me. So at higher prices, I would want to sell more. The PI in my function here, that represents input prices. So this is the price of the resources I need to produce the product, right? So I need workers, I need labor, so the wages of the workers would be an input price. I need raw materials, right? Whatever it is that I'm producing, there are finished intermediate goods I buy, there are other raw materials I buy. The cost of those, the prices of those, that's an input price. I might need a factory or I need equipment. What I pay for rent to those things, that's an input price. I may need land on which to build a factory, to grow crops, whatever it is I happen to be doing. The price of land, that's an input price. Good. If it costs more to produce, let's actually hold off on that for 1 second. Let's do the second one, then we'll put those together. The second one, the T here, be careful because we used T when we talked about demand, but this is a different T. This T stands for technology. Technology is really pretty much the same thing as the production functions that we talked about when we talked about production possibilities frontiers like a week or so ago, right? So the production function tells me how many inputs I need to produce each unit of output. That's what technology really is. So this tells me, how many hours of labor do I need? How much, time in the factory do I need? How many raw materials do I need? Things like that, right? So if I improve technology, it would be needing fewer resources to make each unit of my output. Make sense? So together, input prices and technology basically tell me what it would cost to produce the product, right? Because technology tells me how many units of inputs I need, like how many workers I need. Input prices tell me what each of them cost. So the number of workers I need times the wages I pay, that's the cost of labor. The number of raw material, units of raw material I need times the price per unit, that's the cost of raw materials, and so on and so forth. So together, technology and input prices tell me how much it costs to produce the good. Yes? If it costs more to produce the good, how would that affect the amount that I am willing and able to offer for sale? If it goes up, I would want to sell more or less. I would want to sell less, exactly. I'm profit maximizing. Remember, so this is sort of just the opposite of what we talked about with price. Price increases revenue per unit. This would increase cost per unit, right? So that has a negative effect on profit. So if it costs more to produce the product, I would want to produce less. So an increase in input prices would increase the cost of production. I would want to produce less. An increase in technology would decrease the cost of production, so I would want to produce more. Make sense? Yes? I think that's going to go away when I do this next. Let me erase that. Eraser. N represents the number of sellers, so very similar to the number of buyers. If there's more firms in the group that we're considering, the more firms would be willing and able to offer more for sale. They would want to sell more. E, once again, represents expectations. So just like consumers can have expectations about the future, firms can have expectations about the future. They might, like consumers, have some expectation about the future price, right? A firm might think that, well, right now the price of my product is $100, but maybe in a year I'll be able to sell it for $150. If that's the case, the firm may well want to hold on to the resources they have and not produce as much now, but produce it in the future. So if I think prices are going to go up, I might reduce supply now, instead supply in the future, right? So how I feel about prices in the future can affect supply now. That would be an expectation. Firms could have expectations about any number of things. They could also have expectations about input prices, for example. I'm in contract negotiations with my labor union, so I think input prices are going to rise because of that. Maybe I want to produce stuff now before the price of labor goes up, and so on and so forth. So they could have expectations about lots of things, again, just like consumers, but those would be two examples, input prices and prices. PRG here stands for related goods, again, just like in consumption, but these are a little different. We unfortunately call them almost the same thing. When we talk about related goods, we are referring to substitutes in production and complements in production. So the names are really similar. We call them substitutes and complements, but be careful about what we say in production if that's what we mean. So remember, substitutes in consumption, when we talked about that last time, those were goods that consumers could use instead of, right? I could use, what did we do? Pepsi and Coke, I think was the example we gave, right? So I could drink Pepsi or I could drink Coke. When we think about substitutes in production, these are goods that the firms could produce instead of, right? So goods that basically take the same bundle of resources, right? So I have the same bundle of resources, and I can make this good or that good. Those would be substitutes in production. Some examples, if you have any, please volunteer them. But one example that I frequently use would be cell phones. And maybe the air card that you can plug into your PC, right? So you can connect your PC to the cellular network. These are basically the same components, right? But the firm could choose to make one or the other. In the automobile industry, A lot of, say, like crossovers and automobiles, cars, are built on the same platforms, right? And they're basically the same thing, right? Cars and steel and seats and plastic and engines and things like this, right? So if I have an assembly line that I can produce a car on, an automobile, a sedan, or I could produce a crossover SUV, those would be substitutes in production. Coupes and convertibles, right? The convertibles are just scoops with the tops cut off. Those are all examples of substitutes in production. I don't know. Let's use the SUV and car thing. So if the price of like the crossovers, the SUV goes up, how would that affect the supply, the quantity that the firm is willing and able to offer for sale of cars, if they are in fact substitutes in production? It would go down, exactly, because if I have this bundle of resources and I use them to produce this good, which I want to do because the price is higher and I'm trying to maximize profit, so I would sell more of the thing whose price is going up, that means I cannot then use those same resources to produce the substitute. Right? If I use the steel and the glass and the tires and the engines and so on and so forth to make the SUV, I can't use those same ones to make the car, so that would reduce the supply of automobiles and cars. Yes? Good? Okay. Complements in production. Again, going back to the consumer side, remember when we talked about complements in consumption, they were things that we used together, like peanut butter and jelly, and gasoline and automobiles, cell phones and cell phone plans, right? Those are things we use together. When we talk about complements in production, these are things that are produced together. They are in effect like byproducts. So the act of producing one of the items results in the production of the other item. So the act of producing one results in the production of the other. These are harder to come up with examples usually of these. The silly one that you'll remember are like donuts and donut holes. Okay, I know they don't really make donuts this way, but you know, if you stamp out the middle of this like fried dough thing, right? Every time you make a donut, then you end up with a donut hole, right? Donuts, donut holes. Those are complements in production because every time I make one, I get the other. Some of you might be from farming backgrounds, so if you make milk, right, you might also produce fertilizer at the same time. Think about it. Yeah, there it is. Okay, so I have cows. Okay. So milk and fertilizer might be complements in production. There are a ton of these in the process of refining oil. So if you have crude oil and you're refining crude oil into gasoline, along the way they produce kerosene, right? That's a byproduct, a complement in production. Along the way from producing crude oil, refining crude oil into gasoline, they produce petroleum jelly, right? That's a byproduct, that's a complement in production. And there are a couple other ones too. By the way, did you realize that when they first started refining crude oil, the gasoline was sort of a useless byproduct? It was this thing that we ended up with, and it was this liquid that was like ridiculously volatile and dangerous, and we didn't really have any use for, because before the invention of the internal combustion engine, there was really no use for gasoline. So they kind of like, quickly threw it away or exploded it before somebody got hurt. But the original purposes of refining crude oil were to make kerosene and petroleum jelly. Do you know why petroleum jelly was such a hot product? Vaseline is what we all call it now, right? Because it's one of those things like Kleenex that we've just associated with the brand name. The thought was that petroleum jelly, before there was refrigeration, petroleum jelly was actually used as a cooking fat. It was a solid at room temperature cooking fat that would not become rancid at room temperature, right? Because lard and all animal-based cooking fat products have to be refrigerated. So in the tropics in particular, this was a real problem because they did not have ice boxes. So that's what petroleum jelly was for. I would not recommend frying in Vaseline, but I guess you can. Oh, so I didn't give an example, right? Got so excited about my little random piece of useless knowledge about like the process of petroleum refining. So let's do donuts. We use the Dunkin' Donuts spelling, right, since they do actually sell donut holes. I guess we should call them munchkins, right, because isn't that what they call them at Dunkin' Donuts? It's been a long time since I've been to Dunkin' Donuts. M-U-N, let's try. I don't know how to spell it either. I don't know how I spell it. We'll get with that. Okay, so if the price of donuts goes up, right, then the firm would want to produce more donuts, obviously, because they're profit maximizing. How would that affect the supply of donut holes, of munchkins? It would cause it to go up, right, exactly, because every time I make a donut, I end up with a donut hole. Good? Okay. So remember, realize, substitutes in production, there's an inverse relationship between price and supply. Complements in production, there's a direct relationship between price and supply. Okay? If you look back quickly to our discussion of consumer behavior, this is actually the opposite, right? So when we talked about substitutes in consumption, increasing price led to increasing demand. And complements in consumption, increasing price led to decreasing demand. Okay? So always think of the examples. I think the easiest thing to do is not to try and memorize the relationships, positive, negative, indirect, direct, whatever. Just think about the examples and work them out in your head, right? I'm not a big fan of trying to just memorize stuff. I usually think it's better to understand it, and then you can always figure it out again if you forgot. But that's related goods. Yes? Okay? And the final sort of item that we can throw into the supply relationship is sort of a non-market one. It's a government aspect that might affect the supply relationship, and that would be taxes and subsidies, right? Taxes and subsidies. And these are not like taxes like income taxes or sales taxes or something like that. These are what economists would call indirect business taxes. Indirect business taxes are direct taxes on the production of the good. So an example in the US would be like the gasoline tax. The federal gasoline tax is a tax on the production of every gallon of gasoline. And a subsidy would be just the opposite of that. It would be a situation in which the government provides a payment for the production of a particular product. So it's a negative tax, just the opposite of tax. Yes? So taxes and subsidies affect supply because, in effect, these two can affect the cost of production, right? While these are sort of market-oriented issues related to the cost of production, prices, input prices, and technology, taxes and subsidies also, in effect, affect the cost of production. If you tax the product, then the firm has to pay the actual cost of production, right? What it costs, the resources times what it costs to buy the resources, but then they also pay a tax on each unit that they produce. In the United States, the 52 point whatever federal cent per gallon gasoline tax they would have to pay. A subsidy would reduce the cost of production in the same way. Every time I produce, a gallon of ethanol, I receive a subsidy of X, and that reduces the cost of production. So again, anything that we said that anything that increased the cost of production reduced supply. So taxes would reduce supply, and subsidies, that would be something that reduced the cost of production, so that would increase supply. Yes. Make sense? Good. Okay. So again, just like the problem we had when we talked about the consumer side, here we have a many, many, many dimensional function, right? We have quantity supplied, our dependent variable, we have price, and then a bunch of other non-price determinants, all of these things that would affect the sort of desired quantity that firms want to sell. Again, in order to draw two-dimensional pictures and keep this simple in terms of algebra and so on and so forth, we will perform that same trick, right? The same trick we did before. We will want to hold everything constant except price. Examine the two-dimensional relationship between price and quantity supplied, holding everything else constant. This has another huge advantage, right? If you look at the list of determinants of supply, price, input prices, technology, the number of sellers, producer expectations, the price of related goods in production, and taxes and subsidies, there is only one common independent variable between this and the consumption side, right? On the consumption side, we said quantity demanded was a function of price, taste and preferences, income, the number of buyers, the price of related goods in consumption, and consumer expectations, right? The only thing that's common between that list and this list is price, right? So what this is going to really allow us to do is to examine the relationship between this one independent variable price and both consumers' desired purchases, quantity demanded, and producers' desired sales, quantity supplied. Right? So we have one independent variable that's common between both of them, and that's the one that we choose to look at. And again, if I'm rushing through this, I'm doing it because it's analogous. If you have any questions, tell me to slow down or something. But again, we have all these sort of analogous definitions now, right? We talked about 3 different ways of looking at the ceteris paribus demand relationship. We can use the same 3 ways of looking at the ceteris paribus supply relationship. Namely, we could look at a table, which we'll call a supply schedule. That table will show the quantity of good that a group of producers are willing and able to offer for sale at various prices, ceteris paribus, right? So in this table, when price is 2, quantity supplied is 4. Price is 4, quantity supplied is 6. Price is 6, quantity supplied is 8, and so on and so forth. So the table relates price and quantity supplied. That's the supply schedule. Again, holding everything else constant, ceteris paribus. We could draw a picture of that relationship. So in effect, we could plot the points that are in the table and connect them. By plotting the points that are in the table and connecting them, we end up with a graph that shows the quantity of a good that a group of producers are willing and able to offer for sale at various prices, holding everything else constant. So again, if I plot the point $2 price and 400 units of quantity supplied, $4 price and 600 units of quantity supplied, and so on and so forth, I end up with this line. We call that line a supply curve. A supply curve. So again, it relates price and quantity supplied, ceteris paribus. Note, we're still graphing the way economists do, putting the dependent variable quantity supplied on the horizontal axes and the independent variable price on the vertical axes. So we are still thinking right is an increase, left is a decrease. Or we could write an algebraic expression that relates the points in the demand schedule or the points on the points on the supply schedule or the points on the supply curve to each other. And that would be the supply function. So it's just an algebraic expression that shows the quantity of good that a group of producers are willing and able to offer for sale at various prices, holding everything else constant. So this supply schedule, QS is 200 plus 100p, is the algebraic expression that results in the table and graph that we just looked at, right? If I plug in, say, a price of $4, 100 times the $4 is, of course, $400. And if I then add that to the 200, that results in $600. That's quantity supplied. And again, that's what the point in the supply schedule or the point on the supply curve should. Yes? Makes sense? So again, there's just these 3 different ways of looking at the exact same relationship between price and quantity supplied. The supply schedule, the supply curve, or the supply function. And once again, I will ask you, what is the direction of this relationship in this example? What's the relationship between price and quantity supplied look like? Positive, negative, direct, or indirect? It's positive or a direct relationship. They move in the same direction, right? Whenever price is going up, quantity supplied is going up, right? Price is going up, quantity supplied is going up. The slope, the term multiplied by p, the independent variable up there, is positive. In the table, again, as we move down the table and price is rising, quantity is rising as well. So there's a positive relationship between price and quantity supplied. Again, holding everything else constant. In economics, this is frequently referred to as the law of supply. So the law of supply would simply state that quantity supplied and price are directly or positively related, ceteris paribus. You will note that I put the law of supply in quotes, right? While I did not put the law of demand in quotes, that is because, unlike the law of demand, which economists have been unsuccessful in finding real-world counterexamples of, while the law of supply is generally true, and it will be true for any example that we consider in this class, it is perfectly possible, and there are quite reasonable situations in which supply curves do not have positive slopes. Okay? Again, that would be a topic for an intermediate microeconomics or a managerial microeconomic course, but there are lots of situations in which we would expect the supply curve maybe to have a positive slope over some range, but then maybe actually turn and go backwards It's very common actually in labor economics, in resource economics. You can probably imagine this quickly in your head, right? If you think about how much labor, how many hours of your time you would be willing to supply in the labor market, right? You know, if you can make $10 an hour and your wage goes up to $20 an hour, up to $30 an hour, maybe you would decide to work more hours, right, to make more money. But there would be a point for all of us, I think, you know, when your wage gets to $100 an hour, $1,000 an hour, $5,000 an hour, you know, $50,000 an hour. There's clearly going to be a point at which you would choose to work fewer hours, not more hours as the wage continued to go up, because there's only so much you can do with money, and you would want some time when you can actually enjoy the money, yes? So in that situation, it's pretty easy to understand how, you know, supply curves might not always, for all prices, go in the positive direction. Oh, makes sense? Yes. Then finally, the last sort of thing, so we're done with all of these definitions in regards to supply and demand, would be to, again, think about those two terms, quantity supplied and change in supply. Yes? So again, very similar to demand, we have this term, the change in quantity supplied and the change in supply. Again, the distinction is whether we are talking about price changes or non-price changes, right? Some of the other determinants of supply. If the price changes, that is going to be a change in quantity supplied. The ceteris paribus assumption holds, so we can stick to the supply curve or supply schedule or supply function that we have and just move along that curve, schedule, or function. So in this case, again, with price rising from $4 to $8 for some outside reason that we're not going to discuss yet, right? If price rises from $4 to $8, then we would expect the result to be a movement along the supply axes as quantity supplied rises from 600 units at $4 to 1,000 units at $8. That movement from the point where price was $4 and quantity supplied was 600 units to the point where price is $8 and quantity supplied is 1,000 units, that movement upward along the supply curve is an increase in quantity supplied. It's an increase in quantity supplied because, again, if we look at what's happening to the measurement axes, to the q-axes, we are moving to the right along the q-axes. Okay, so this is an increase in quantity supplied. Make sense? On the other hand, if something other than price changes, so one of the non-price determinants of supply, that would be input prices, or technology, or taxes or subsidies, or the number of sellers, or producer expectations, or the price of related goods in production. Yeah, that's I thought I'd forgotten one or something, but that's it. So one of the non-price determinants of supply, if one of those changes, now the producer's behavior will be different at every price. Right? If technology changes so I can produce the product more cheaply, it doesn't matter whether the price is high or low. Comparatively, I now want to sell more because technology has improved. Right? So at every price, the relationship between price and quantity supplied has changed. So I need an entirely new supply curve. The ceteris paribus assumption doesn't hold. The old supply curve was given a particular level of technology. If I now have a different level of technology, I need an entirely new supply curve to reflect the new level of technology. This is the change in supply, and the change in supply. So by way of an example, again, you know, if say input prices decrease, right? So we have a decrease in input prices. I used an increase in technology. They're going to have the same effect. It doesn't matter. So if input prices decrease, then producers would want to produce more of the good no matter what the price, right? So you know, they used to want to sell, you know, at $2 some quantity 400. Now they're going to want to sell more. They used to want to sell 800 units at $6. Now they're going to want to sell more, and so on and so forth. So this is going to lead to, at every price, quantity supply being higher than before. So that will shift the entire supply curve to the right, right? The new supply curve, the red one in this picture, is going to be an increase in supply because it reflects a higher quantity supply at every price than the blue supply curve. Yes, so the red one is an increase in supply. Notice, by the way, this is the place where students get that up and down, left and right thing messed up. Okay, this is an increase in supply because it lies to the right of the old supply curve, but it is down. right? It's below. I will guarantee that no matter how many times I say this between now and March 11th or whenever we're taking our midterm exam, when you're asked to draw these on the exam, and you will be asked to draw these on the exam, someone in this room will, put it up here and say it's an increase. And that's to the left, it's a decrease. Or they'll draw one like this and say that's a decrease because it's lower. Right and left, not up and down. This is an increase because at every point on the red line, it's further out the quantity axis.